Hi everybody, it's Dr. Bardot. I'm going to help you walk you through a little bit with the light theremin tonight. So hopefully you can get into Tinkercad like I have here, and hopefully you can pull up from the Canvas page the light theremin instructions and navigate to the Circuits tab of Tinkercad, and we're going to create a new circuit. We are going to go ahead and use the things we always use. So I'm going to grab a Uno here. I'm going to rotate mine so that it's vertical. I've decided that that's the way I like it. Now we're going to bring over a breadboard and also rotate that and put them pretty close. And now I'm going to you should read this explanation of light theremin. It talks about PWM, which we talked a little about in class today. And it says here that a piezo is a small element that vibrates when it receives electricity. When it moves, it displaces air around it, and that creates sound waves. So a piezo can be used to make sound, but it can also be used to as a vibration sensor. So when it vibrates, when the piece inside it vibrates, it will send electricity through a circuit. It has to vibrate a lot to send. So it's not a very sensitive vibration sensor. All right, so we're going to set up this circuit as we see it here in our book. Okay, so yeah, we'll do the same thing over here. Zoom in a little bit, maybe. There we go. We probably just need about that much. So as always, 5 volts to the power, and I'll make that red. And ground to the ground, and I'll make that black. And now I'm looking for a piezo. So here's one of those. It's quite big. I'll rotate it so that it's in 2 different spots. Over here, it looks like one side of my piezo will go to ground. And since that's going to ground, I'll make that black. And the other side of my piezo is going to pin 8. And I'll make that yellow just to match. Over here, I'm going to have a photoresistor. A theremin is a kind of instrument that people play. This isn't quite exactly how a theremin works, but a theremin works through electrical fields and it's a very weird thing where you don't touch it, and it makes all these spooky sounds, that kind of noise that you might have heard in an old horror movie. That's a theremin. Okay, so we're going to put 3 wires here. We're going to connect my photoresistor to power. So we'll make that red. We're also going to use the photoresistor as an input. So we'll put an analog input there. If you've never seen this before, you can kind of create little bends in your wires so that they're not in the way. We need a special resistor here. I'm going to scroll up, and I'll see that it's a 10 kilo ohm resistor. Okay. And so I'll just get one of those, rotate it, and that connects the photoresistor to the ground on the side that I have my sensor, and I'll make sure it's 10 kilo ohms. Okay, 10 kilo ohms, yeah. So I've got my circuit. So that's good. I'm good with that now. I'll go ahead and put the code in. Go to text, say continue, and take out everything that's in void and loop, but try and keep those braces. And now I'm going to scroll through to find my code here. So the first thing I'm going to do is I'm going to set up these variables that are going to be used throughout the program. So we're going to have a variable called sensor value, which isn't too surprising. We're going to have a variable called sensor low, which is 1023. It seems a little weird for that to be low. We'll figure that out later. Sensor high, which is 0, which is a little weird since 0 is the lowest it could be, but let's just go forward. And we'll have a constant integer, so this will never change, called the LED pin, equals 13. It turns out on every Arduino, there's a little light right here, and we can use that. That's an LED that's on our Arduino that we can control through pin 13. And it's just a helpful thing so that we know things are working. All right, let's go back to the code. We've got all of the things done for before the setup, in void setup. We're going to pin mode 13, well, LED pin, which is 13, as an output. And we're going to set that up to be high. And now we're going to use something called a while loop. And that's just going to go until something called millis is less than 5,000. So what that is the first 5 seconds. Millis counts how many milliseconds have gone by since your Arduino has been reset. So in the first 5 minutes, we're going to just try and get a sense of what possible readings can come from our sensor. Okay, so we'll do sensor value is analog read A0 if the sensor value is greater than sensor high. So if we think about this, when it starts, this is probably going to be true. We are going to, the very first value we read will probably be bigger than 0, which is what sensor high is now. And so that will be our highest value we've ever seen. And so what we want to do here is in the first 5 seconds, sort of record what values could be the highest, okay? And then also, if sensor value is less than sensor low, then that's a new record for the low. So we're going to do that in the while loop. And then we're going to turn off that LED pin to say that we are done finding the highs and lows. Okay. In the loop, we're going to do this, a much simpler thing. Okay. We're going to read what's coming out of that photoresistor, what voltage is coming out. And then we're going to make a pitch based on that reading. So most of us did this today with the pot value and the servo position, but this is another example of that. So we know what the lowest the sensor can be because we went and found that in the first 5 seconds of our code, and we found out what the high could be in the first 5 seconds of the code. And then we're going to have the lowest pitch we have be 500 hertz, and the highest pitch that we're going to have is 4,000 hertz. Okay. Then the Arduino has a command that makes a tone at using a certain pin, so pin 8, because we have connected our piezo to pin 8. The pitch will be what we figured out from the sensor value on the photoresistor. And we're going to play that pitch for 20 milliseconds, which isn't that long, so that we can then go back and do it again. We'll put a delay in here as well, so that it just gives us a little time to reset and refigure everything. And that's the whole code. That's the whole code. Okay. Let's see if. So I'm going to want to sort of slide this over. Let's see if it. So I have some mistakes. Okay. What I didn't do here is I didn't declare sensor value. Okay. Oh, I did declare sensor value up above, but I didn't spell it right. So I have to spell that better. And so now it all compiled. You can see it did that. So it's not going to make any noise for the first 5 seconds because it's trying to figure out the highest and lowest it could possibly be. So I'm going to make a little more room for myself here. Okay, because I want to, once I start the simulation, I want to work and change the sensor, the photoresistor, to different levels so that it can find out what the highest and lowest it is. So this is an important thing to do. You can see my LED is on here. When that turns off, it'll start making noise. And I'm just sliding this back and forth so that we're getting a sense of what those highs and lows are. And you can see in my simulator time, I'm at 4 seconds. At 5 seconds, this light should go off, and it should start making some noise. And that's it. It's doing what it's supposed to do. So the lighter it is, the lower the pitch. The darker it is, the higher the pitch. That's annoying. All right. If you've got it to make that kind of noise, then it's working. And I hope you have a good night. I'll see you tomorrow.